Okay, so today we're going to go over some basic factoring review. Anytime we factor, the first thing that you look for always is the greatest common factor, which we call the GCF. Okay, the greatest common factor is the largest number and or variables that can be taken out of each term. Okay, largest number and or variables that can be factored out or taken out of each term. Okay, so that's what we'll look for first, always. So for an example, let's go ahead and look at these couple, finding the greatest common factor. So I look at the number part first. If I look at 3 and 18 and -6, their common factor would be 3. Okay, so my greatest common factor that's a number would be 3, and then I look at the variables. Okay, they all have x variables, so the maximum number of x's I can take out of all 3 would be just x to the first power, because once I take out an x to the first power, this third term would no longer have an x. So once I take that out, remember I have to write what's left over once I take that out. And to determine what's left over, I can write it as a division. Anytime we factor something out, we're actually dividing each term by that greatest common factor. Okay, I won't require you to write this out on an exam or anything like that, but just to help with our understanding. So over here to the side, I'm going to go ahead and write our greatest common factor of 3x, and then in parentheses we write what's left over once we've factored that out. So the first term, notice my 3's will cancel, and I can cancel 1x on top and bottom, okay, which will leave me with x to the 4th power in the first term. My second term is positive. 3 goes into 18 6 times, so I'm left with a 6 coefficient, and then I can cancel 1x on top and bottom, which leaves me with x to the 1st power. Okay, and then the last one, 3 goes into 6 2 times, so I'm left with a -2, and my x's cancel, so I'm left with no x's. Okay, so this is my fully factored answer. Okay. On the next example, same thing. We're looking for a common factor. Notice just because these are in parentheses doesn't mean that they're not still factors. So as long as they have the exact same variables raised to the exact same powers or the exact same quantity, we can still factor that out. So looking at the coefficient part, okay, I don't have anything in common. 4 and 7 are not common factors. One has an x, one doesn't. So that doesn't help me at all. But I do have this quantity in common, right? I have this quantity x plus y in both terms. So I'm going to go ahead and call that my greatest common factor, the quantity x plus y. Anytime we're dealing with quantities, you have to leave those parentheses around it to signify that that's a quantity. Okay, and then just like before, I'm going to go ahead and write over here my quantity x plus y, and then I want to write in parentheses what's left over after I factor that off or divide it off. And I apologize, I'm a little sick, so my voice is stinky right now. So we take our original expression, 4 times the quantity x plus y, minus 7x times the quantity x plus y, and I'm going to divide each term by that greatest common factor. Okay, when I divide each term by the greatest common factor, notice what happens is, well, it cancels off. Okay, my first term, all I'm left with is just a positive 4. My second term, all I'm left with is the minus 7x. Okay, and now I'm completely factored. Okay, so greatest common factor, not too bad. Looking for what's in common, write in parentheses what's left over once you take out that common factor. Next one I want to refresh us on is factor by grouping. Factor by grouping is used for 4-term polynomials. We still look for a greatest common factor first, always. But then after that, if we have 4 terms, we use grouping. So looking at this first example, I'm going to look at all 4 terms first to see if they have anything in common. So I notice the first 2 both have x's. The third one has an x, and the last one has an x. They don't have any other variables. Oops, excuse me. They don't have any other variables in common. So I'm going to go ahead and take out an x. Okay, my greatest common factor is an x. And notice when I take that x out, I won't be left with anything else in common. Okay, now I'm not going to write out the dividing off the greatest common factor like I did before. I'm just going to go ahead and do it. So if I have x out here, if I take one of these x's away, this is going to become a 1. So I have ax to the first power. If I take this x away, I'll be left with just minus by. Oops, sorry. In the third term, if I take an x away, I'll still be left with an x squared. So that leaves me with 2a squared x squared. And then my last term, if I take one x away, it will leave me with just one x in that term. So I'll be left with negative 2abxy. Okay. Now, so this is what we did in the last step. Now I actually want to go into grouping. So I'm going to use a different color. When we group, I'm just going to group the first two together and the second two together. And I'm looking for, what do these pairings have in common? What GCF do these pairings have? So if I look at this first pairing, I'm looking for a GCF between those two terms. So notice, they don't have anything in common. If they don't have anything in common, the only thing we can divide out or factor out without changing the value is a 1. So I'm just going to say my greatest common factor here is a 1. So I'm going to go ahead and take out that 1, which obviously when I divide by 1 doesn't change the value of the expression, so it leaves me with ax minus by. So that one wasn't very exciting. But let's look at the second one. We're looking for a greatest common factor between these two terms. So notice right away they have a 2 in common, so I can take out a 2. They also have an a. I can take out an a to the first power. They have a b. Oh no, they don't have a b. I lied. They do have an x, and they don't have a y. So 2ab is my greatest common factor for those two terms. So I'm going to go ahead and write, since it's positive, I'm going to put plus 2ax. And then in parentheses, again, I'm going to write what's left over from these two terms now that I've taken that greatest common factor out. So if I take 2ax out of this first term, which is actually my third term, I'm only going to be left with 1a and 1x. Out of my fourth term, if I take out, excuse me, oh my goodness. Okay, on my fourth term, if I take out 2ax, my 2a will be gone, and I'll be left with only by. Okay, so we're almost done with grouping. Now notice this one looks like the second example we did on greatest common factor. They have a greatest common factor that is a shared quantity. Okay, so now that these quantities are in common, I'm going to go ahead and factor those quantities out. Okay, so I'm going to go ahead and say here, my greatest common factor is ax minus by. Okay, so if I take out ax minus by, what I'm left with from this term, that would cancel, and I'm left with just this positive 1. If I take ax minus by out of the second term, all I would be left with is this 2ax. Okay, so I've completely factored the 4 terms, but we have to remember we had this original greatest common factor that we took out at the beginning that was an x. So make sure at the end we put that back on. Okay, so I'm going to write over here to the side my final answer, the x that I took out in the very beginning, and then my final answer, which was ax minus by times 1 plus 2ax. Okay, so notice I started with 4 terms, took out a greatest common factor, and then the remaining 4 terms I paired into 2-term pairings, took little miniature greatest common factors out so that they would have the same leftover. Okay, so my 4 terms became these 2 factored quantities, and then greatest common factor out front. Okay, so that's my final answer on that one. Let's look at another one. Here's another one with grouping. Remember, anytime we do grouping, we always look for a greatest common factor before we do anything else. So my greatest common factor from all these terms, they don't all have numbers and variables when I look at their coefficients. right? This one has no coefficients in the variable. This one has no variables in the coefficient. This one has no numbers in the coefficient. So I know there's nothing I can take out that way. But something I do notice that they all have is the quantity y minus 5. Okay, they all have this quantity y minus 5. So I'm going to go ahead and call that my greatest common factor is the quantity y minus 5. I'm going to go ahead and take that out of everything. Okay, if I take out the quantity y minus 5, my first term is going to be left just with this 2x squared. My second term is going to be left with 4x. Okay, my third term will be left with just negative x, and my fourth term left with just negative 2. Okay, so now I have it down to 4 terms that have nothing in common, so now I can go ahead and group. Again, when I group, I'm just pairing 2 terms at a time and looking for greatest common factors within those pairings. So if I look at my first pairing, the greatest common factor that I see is 2 and 4 both have the common factor of 2, and my x's, I can take out 1. So if I take out 2x out of this first pairing of terms, when I divide that off, my first term will be left with just 1x. My second term will be left with 2 because 4 divided by 2 is 2, and then my x is gone because it's part of my greatest common factor. Now what I'm hoping is that after this second pairing that I'll be left with an x plus 2. I want my leftovers to look the same. So when I look for a greatest common factor here, I'm looking for a number or variable that when I take it out, it will leave me with a positive x plus 2. So here, we don't have any common variables or numbers, which means all I can take out is a 1. But I can take out either a positive 1 or a negative 1. In this case, I'm going to take out a negative. If I take out a negative 1, it will change the signs. So I'm going to write my negative 1 out here, and notice if I take a negative 1 out of negative x, that will change it to a positive x. If I take a negative 1 out of negative 2 by dividing, it will also leave me with a positive 2. Okay? And then again, to complete my grouping, now I see that they have this quantity in common, this x plus 2. So that's my greatest common factor. Okay? So I want to take that out. If I take out x plus 2, that will leave me 2x from my first term and negative 1 from my second term. Okay, this is where these are coming from. And then I always have to remember, did I have a greatest common factor at the very beginning? Which here, yes, I did. I had this greatest common factor that was actually a quantity. So I need to put that quantity back on the front again. Okay, so my final answer is going to be y minus 5, which is my original greatest common factor, and then the factors I got from factoring the remaining 4 terms, which would be x plus 2, 2x minus 1. And now I have my expression fully factored. Okay. We always want to start off by looking for a greatest common factor, just like before. So here, if I look for a greatest common factor, notice they're all divisible by 2. So I'm going to go ahead and take that 2 off. When I factor that 2 out, I'm left with x squared minus 9x minus 22. Okay. Now to use the sum product chart, my sum is always my middle coefficient. So here my sum is negative 9. Okay. My product is always my leading coefficient times my constant term. So I'm going to say leading times constant. So here my leading coefficient is a 1 because there's no number in front of the x squared. So 1 times my constant term, which here is negative 22. So 1 times negative 22 is negative 22. So I need something that sums or adds up or combines to negative 9 that I can multiply to get negative 22. So looking at 22, let's just think about that. 22 we can get by doing 22 times 1, or we can get by doing 11 times 2. So I'm looking at what pairing can I combine to get 9, right? Or negative 9 rather. So the pairing that I need to use is this one, this 11 times 2. Now I just look at what their signs have to be. To get a negative 9, one of them is going to have to be negative. So if I do negative 11 times 2, that gives me negative 22. And negative 11 plus 2 gives me the negative 9 that I need. Okay, So I'm going to go through and actually show you how to replace the middle term, and then I'll show you a shortcut later. So now that I found this pairing, what I'm going to do is I'm going to replace this middle term with this pairing of numbers that I just found that equals that middle term. Okay, so I'm going to go ahead and rewrite my polynomial over here. I'm going to leave off the 2 for a minute. I'm just going to put a star so I remember there's a greatest common factor. So I have x squared. Now instead of writing 9x, I'm going to write minus 11x plus 2x. And then my last term, which was negative 22. Okay, and now I have a 4-term polynomial, which is what we just got done doing. We factor by grouping. So when I group the first two, what they have in common is an x. If I take out an x, I'll be left with x minus 11. Then I look at my second pairing. What they have in common is a 2. So I'm going to take out a positive 2, which leaves me with x minus 11. Okay, and then again I look for greatest common factor, which now I see that they have this quantity in common. So if I take out my x minus 11, I'm left with x plus 2. And then don't forget your greatest common factor that you started with. So this factors into x times x minus 11 times x plus 2. That's my final answer. So the shortcut I wanted to show you, and this only works when the leading coefficient is 1. So I'm just going to put a note over here. Okay, only when the leading coefficient is 1, the numbers in the chart will be the numbers in the factored quantities. Ooh, quantities. Okay, and what I mean by that is notice the factors that we found are negative 11 and positive 2. And notice when we factored this, it factored into x minus 11 and x plus 2. Now that only works when our leading coefficient, which is the number in front of the x squared, is a 1. Okay? If there was like a 3 or a 4 or negative, anything there, this doesn't apply. But when it's only a 1, when the leading coefficient is a 1, then it's nice to remember this shortcut, because then you don't have to go through the whole replace the middle term and group. Okay. All right, let's look at another one. Okay, I'm going to erase that so it's not too nasty. I'm going to go ahead and put a big old bam over here so that we can reference that. Okay. All right, scrolling down. All right, so on this example, I want to start like I did all the others, looking for a greatest common factor. My greatest common factor on this one would be, let's see, they're all divisible by 3, so we can take out a 3. And they all have x's. They don't all have y's, but they all have x's. And x to the first power is our lowest one, so we can only take out 1x. When I take out 3x, what I'm left with is x squared minus, excuse me, when I take out 3x out of my middle term, I'm left with, oh, not 3. I'm left with xy. And when I take 3 out of negative 90, I'm left with negative 30y squared. Okay. So on this one, I could use the shortcut because my leading coefficient's a 1. However, I'm going to go ahead and show you how to replace the middle term just so that we see it one more time. Okay. So to replace the middle term, remember we do sum product. My sum is my middle coefficient, which in this case is negative 1. Okay. And my product, remember, is my leading coefficient times my constant. So in this case, my leading coefficient is a 1 times my constant, which in this case isn't a constant because we have a y squared, but it is our third term. Okay, so which is the negative 30. 1 times negative 30 is negative 30. So I'm looking for a pair that multiply to give me 30 that I can combine to get a 1. Okay, so to get 30, we could do 3 and 10. We could do 30 and 1. We could do 15 and 2, or we could do 6 and 5. So if I'm trying to get a 1 6 and 5 is the one that's going to give it to me. I just have to figure out what my signs are going to be. To end up with a -1, I'm either going to use -6 plus 5, or I'm going to use +6 minus 5. Okay, my bigger number needs to be negative so that my answer is negative. So not this one. We're going to go ahead and use this pairing. So just like before, I'm going to take the numbers in the chart and I'm going to use that to replace this middle term. Remember, when we do that, the middle term has to keep the same label. I'm going to go ahead and put a star over here so I don't forget about my greatest common factor at the end, and I'm going to rewrite my polynomial. I have x squared. I'm going to use the two terms from my chart, which is -6, keeping the label from the middle term before, which is xy, plus 5xy. And then my third term, which is now my fourth term, -30y squared. Okay, and then I go ahead and group. So out of the first pairing, I can take out an x, which leaves me with x minus 6y. And then over here, I'm hoping to be left with x minus 6y because I want these to match. So what must I take out to be left with x minus 6y? So what I need to take out to be left with x minus 6y from these two terms, they're both divisible by 5, and they both have a y. So I'm going to take out a 5y. Okay? When I take 5y out of both of those terms, I'm left with my x minus 6y that I wanted. And now notice my quantities match. So when I take out the quantity x minus 6y, I'm left from my first term with x, and from my second term I'm left with 5y. Okay, don't forget to put on your greatest common factor from the very beginning, which was 3x times x minus 6y and x plus 5y. Now, we talked about the shortcut. This one you could actually use a shortcut on because my leading coefficient was a 1. I just want to show you something that's a little tricky. Notice we had an x squared at the beginning and a y squared at the end. That means in each of our little factors, we're going to have an x on the first number and a y on the second. So here, our numbers were -6 and +5. Notice our numbers in our solution were -6 and +5. You just would have to remember to put the y on afterwards if you use the shortcut on this one, okay? All right, I'm going to show you sum and difference of squares, and that will be the last couple that we do. A sum and difference of squares is for two-term polynomials, and we're hoping that the first term and the second term are perfect squares. Okay, always, just like before, we look for a greatest common factor first. So my greatest common factor of this one, and there will be some that don't have greatest common factors, just note to self, but on these I try to put it in there so that we get used to looking for it. My greatest common factor here, they're both divisible by 4, and they both have v's. So if I take out the minimum number of v's that appears in one term, that would be v to the 4th power. Okay, so if I take out 4v to the 4th, my first term by 4's would cancel, and I'd be left with v squared. Okay. Second term, 64 divided by 4 leaves me with 16, and then my v to the 4th is gone because that was the greatest common factor that I took out. Okay, now for sum and difference of squares, I'm going to go ahead and write over here off to the side. Anytime we have something like a squared plus b squared, this is not factorable. Okay. Anytime it's a sum, meaning there is a plus sign there, we cannot factor it any further. The only thing we can do is take out a greatest common factor. Okay, which here we've done. Now, ours is not a sum, ours is a difference or a subtraction. So a squared minus b squared, this always factors into a plus b times a minus b. So the first base that's being squared plus or minus the second base that's being squared. Okay, so these are our formulas. This is something that would not be given to you on a test. You definitely need to remember that. So now all I need to know is, do I have a sum or a difference? If I have a sum, I'm done. If I have a difference, I can keep going. So notice I have a subtraction, so I have a difference. So I just need to figure out what is the base that's being squared to give me v squared. In this case, my base would just be v. And then what am I squaring to end up with 16? The number that I have to square to get 16 is 4. So then I just use my formula over here. I do my first base plus or minus my second base in my factors. So what this factors into is 4v to the 4th times my first base plus my second base, so v plus 4, times my first base minus my second base, which is v minus 4. And now I am completely factored. Okay? Let's look at another one. On this next one, again, I look for a greatest common factor first. My greatest common factor here, they're both divisible by 2. They both have x's and y's. Okay, the maximum number of x's I can take out of both terms is just x to the first power, and the same thing with a y. So I'm going to go ahead and take out my 2xy. When I take that out, that will leave me y to the 4th minus, now 128 divided by 2 is 64, and then I took the xy off, so I'm left with this. Okay, so now I want to go ahead and see if I can go further. I have a difference, not a sum, so I can keep going. So I need to identify what am I squaring in order to get y to the 4th. Okay, so in order to get y to the 4th, the thing that I would have to square is y squared, right? Because y squared squared is y to the 4th. So the base on the first term is y squared. The base on the second term, what do I have to square to get 64, would be 8. Excuse me, 8. So I'm going to go ahead and write out what I have so far. Let's see how much paper I have. Yeah, I'll go ahead and write it out this way. Alright, so I have my greatest common factor, which was 2xy, and I'm going to go ahead and factor using the two bases that I just found. So I do my first base plus my second base, so y squared plus 8, and then I'm going to do my first base minus my second base, so y squared minus 8. Okay, and then I look, am I fully factored? Okay, if I look at my first pink factor, y squared plus 8, I can't go any further. They don't have common factors, and it's a sum of numbers, so I can't do anything else. Okay, now on the second one, however, I could go a little bit further, right? Y squared is a base of y, and then 8, well, it's not really a perfect square, but I'm going to go ahead and show you how we can work it if it was a perfect square. Since it's not a perfect square, I'm just going to go ahead and say that the base would be square root of 8, right? Because if I square the square root of 8, it gives me a positive 8. So I'm going to just use that this one time so we can see where it would go. And then I can go ahead and break that up because it's a difference of squares, so to speak. So this would give me 2xy, okay, times the pink factor that I couldn't go any further with, which is y squared plus 8. And then this last one I can break into two more factors by doing my first base plus my second, so y plus the square root of 8, and my second base, my first base minus my second base. Okay. Now in my math lab, I will go ahead and note, I think you can stop at this step right here. Okay. But just for the sake of showing you that they can keep going and going and going, I wanted to go ahead and work this one out all the way. So let me go ahead and circle that. Okay, so now we've seen how to find a greatest common factor. We've gone over factor by grouping, which is for 4 terms. We've gone over using sum product, which is for 3 terms, and then now sum and difference of squares, which is for 2 terms. So that's our quick review on factoring. Hopefully you've seen these before, but if not, that's fine. This is the worksheet that I would assign to my lecture class. You're free to do it if you want. You don't need to hand it in. Since you're in the web class, I have an assignment in my math lab titled Pre-E1.1 Basic Factoring. You can just open that and work that.